Advanced ETL testing, a complete solution to test complex data transformations. Let's start with a quick definition of ETL. ETL is extract, transform and load, basically moving data between systems or preparing it for use by business intelligence tools. A large percentage of development is spent moving and transforming data. A transform is preparing data for use by message layers, calls to APIs and flat files, which are then moved on into other systems. Testing data transformations is difficult as it relies on complex input and difficult to calculate expected results. Most testing relies on taking production data with a few edits to simulate different data scenarios. And a big problem, if a requirement changes, it is very time consuming to check every existing test case to see if it's still a valid test. And there is usually very little negative testing. So what is VIP and how does it help? VIP is a complete and customizable testing framework that has 5 major components. The first is Test Modeler, a SaaS-based BPMN tool to model processes. It will automatically identify the optimum set of test cases using advanced coverage techniques, and it can directly support model-based design or BDD or TDD. At its heart is a powerful TDM engine that lets you make sure you have the right data in place to support your automation. Everything can be defined using Excel, reducing time learning new tools and letting you reuse your existing test assets. The framework has direct support for Selenium and Appium, plus can connect to virtually any API. It lets you use your own homegrown test framework, as well as supporting the major automation tools such as Eggplant, Parasoft and Perfecto. We can virtualize endpoints and build intelligent and matching request-response pairs, spin up sandboxes on demand, as well as supporting all message types. Finally, we can integrate with your DevOps toolchain and help you integrate your software lifecycle so you can build up an accurate map of dependencies and start moving into the world of AI-driven development. So, how can VIP help with ETL and business intelligence testing? It's a practical and easy to use toolset to model the transformation rules and synthetically create the input test data. VIP will create all the combinations of data, ensuring no scenario gets missed. It uses business process models to define the transforms, and it uses Excel formulas to define the test data rules. Inside Excel, we have a comprehensive library of test data functions. VIP has its own ETL automation framework, or we can integrate with your own automation framework. VIP calculates the expected results and compares them with the actual results, and VIP can connect to multiple types of message formats. So if we look at an ETL process, you have input files that are used by the application, that's the system under test, to transform, validate, prepare and load into a target system. This could be used for business intelligence systems, dashboards, or in batch and messaging systems. So you start with Modeler. That lets you define the core logic of the transform. You can then define the nitty-gritty data rules inside Excel. VIP will then calculate the test cases and assemble the input files for the transform, as well as defining the expected results. You then run the transform using our framework, and the results are captured, analyzed, and the results are fed back to Modeler and on into your ALM system. So onto quite a technical demo now, where we will take a transform requirement, build up the tests, run the transform, and look at the results. There's a lot in the VIP framework, however the demo will focus on just 2 of the components, the Modeler to define the logic and the TDM engine to define the data rules. I've broken up the demo into 6 different parts so you can skip through to the bits you're interested in. Firstly, how to model the transform logic, then exploring different coverage techniques, adding in the data rules, run the automation harness, look at negative testing and subflows, and then a little bit more on data rules. So let's firstly take a look at the requirements document. You can see it's in a Word document, which is fairly typical, or it could be an email, or it could be a user story, and it's to do with phone agreements and their associated insurance requirements. There's 4 parts to the file structure with their associated fields inside, and you can see that there's a little bit of logic which we need to model. If an insurance contract occurs at the beginning of the month and is cancelled within 15 days, no invoice is issued. If it's taken on a sale day, the cost reduces. The insurance date is the same as the agreement date, and sale days can be any day in the month. So let's go into Modeler and start modeling this. So we're in our browser where we brought up Test Modeler. I've chosen the project I'm interested in. There's some folders, phone contracts. There's a couple of models already which we'll look at later, but let's just start with a blank canvas. So you can see it's pretty straightforward to use. So we're just going to drag in our actions. We need a start and an end, and we're going to start dragging in some tasks. So thinking about the logic, the first thing we need is a phone agreement. And we need to join that up with a start, like so. Let's just move that around a little bit. And the next thing we need to think about is a decision. So let's come in with the decision, and what we're going to be looking at here is what the day that it was purchased. So look at day purchased, like so. Let's just join that up. And what we're going to do is add in another task now up here, and we're going to just join that up like so, and we're going to call this is the beginning of the month, which is in the first 15 days. Just add in a task which is less than 15 days. So that's that. The next thing we might be interested in is whether they've cancelled it. So we can come in and build a condition here. So cancelled, and we come back to our 15 days like so, and onwards, and we could then come up and say cancelled, yes, like so. So you can see it's pretty straightforward in terms of how you actually start building up the model. Usually it's quite good to write it down on a little piece of paper first before you start. Now let's go and look at one that I created earlier. So here you can see this is the model that's been defined. It's pretty easy to understand, it's very visual. I've actually split it into two, and we're going to focus in this part of the demo and just on the positive test cases. So this is valid data, and this bit down here is to do with validation rules. But you can see I've created the phone agreements, the day it's purchased, less than 15 days, more than 15 days, cancelled, and we've had a pretty good stab at being able to define the logic that exists in the model. Now once we have our model, we can start looking at the test cases. In the model we've defined the positive happy path logic. In other words, how to process the data is defined in the requirements. You can see in this case that the dates are pretty important to the type of outcome that is required. Now we have several different coverage profiles, but I've just created a blank one called coverage so we can have a little look. And what we can do then is if you click on coverage, there are, first of all, we've got features and filters. Talk about that a bit later, but we're going to ignore our invalid data, which was the bit down the bottom, and we're just going to work on the valid data. Now there are different levels of coverage, so if we just start with low and save that, now what I'm going to do is just generate those tests. So we'll just click on generate, and you can see it's created 3 paths. Now let's just go and have a look at them. And we can click on each path and we can see basically every block has been covered. Now let's go back and change our coverage, and we're going to change the coverage to medium, save it, regenerate, and it's created 7 paths. So let's just refresh. Now you can see that we're hitting more of the combinations here. And finally we're going to go back to our coverage and we're going to set it to exhaustive. And click on generate again. And there are 15 paths, and we'll just click on refresh. And you can see every single combination of potential data scenarios has now been created for us. So once we've decided on the type of coverage that we want, I've stored them in a profile called all tests. Now we're going to download the combinations and merge them with our test data definitions. You could do everything inside VIP Modeler, however I usually find it better to split the two. So the next part of the demo will focus on how to define the nitty-gritty data rules. So I've split the screen into two. So on the right hand side we've got the original requirements document with a description and some of the rules so I can see what I'm up to. And on the left hand side you can see I've just created a very straightforward spreadsheet. And with the spreadsheet we've got the various components or tables or file parts of the file with the various columns and fields down in the first column. Now you can see here that I'm using actually Excel functions where I'm actually referring across to other values. So if we maybe take a look at something like the invoice and we look at the invoice amount, you can see that we're actually looking at the agreement total and the insurance total as well, and we're summing those up. So as you move around you can see we're referring to, we've got various little bits of logic in there, we've got various if statements and the like, and it's very straightforward just to use normal Excel type functionality to be able to see exactly what's going on and define the relationships and the rules and the sums and the averages, etc. that you need. If you needed to add in a new one, maybe you want to add in an address, you could come in like so, and if you type in equals datagen, you will get our list of TDM functions, and there are hundreds of them. So maybe I want to come in here and create something like a full address. Just click tab like so, press enter, and now we've got a full address. Now that would obviously vary every time you run this. Some of these obviously relate to other fields and they would be more fixed. There is a link now to Test Modeler, and if we look at a worksheet called test case data, now in here what we've done is we've actually come in and we've got agreement days, cancel after days, credit note, insurance, sale days, etc. So in a moment I'm just going to go back up into Modeler and show you how we're going to map these. So these are in fact sort of driving the logic of the test data itself. So if we go into agreement or insurance, you will see contract date. If test case data R2C10 is set to Y, then we're going to include an insurance. So there we are, like so. So let's pop back up to Modeler. So if we click on the test data tab, what we've got here is we've defined a bunch of variables. You can import these, but you can see we've got agreement days. Here's the value, insurance, yes, no, like so. And then what you do is you can come in and just click on an assignment. So if we click here, say day 15, we've got an agreement day set to 1, and if we come down here we've got an agreement day set to 16. So as we're moving through our logic, we're setting values. So here we've got insurance reduced cost with an R, insurance Y, like so. So this is how we are mapping the logic back down into our spreadsheet. Now if we go to the tests, so let's go to all tests like so, and if we download the data, let's just download VIP output, what you'll see, let's just open this up, is we've got the definition of all the various tests with the test names, got some internal stuff, but you can see here that we've got the agreement day, the cancel days, the credit notes, the invoices, etc. So this is in fact the sort of map of the 16 different paths through the model, and then what we're going to do is map these values then to our test data spreadsheet. So that value will be set to Y or N, and then if we go here we'll see that value that would then get picked up. So we're going to actually take this definition of the data and we're going to merge it when we run our automation with this CSV file which contains the model logic. So once we've downloaded the files, what we can do is run the harness. In this case I'm going to run it manually. Normally this would be controlled by your framework, so that it's running in batch. So as the job runs, VIP will create a set of files so you can see the tests and test data are being created. So we'll watch that run in a second, and this is a useful check to make sure you got it right. It's a nice way to sort of debug to make sure your automation is working correctly. So you can see the jobs run. We'll just nip over to Slack where we've been notified what happened, and actually 4 of the tests failed and 11 of them passed. So let's go back and have a quick look. So what you'll see as the job is running, and we're running it with an identifier of batch 43. So we start off with a basic definition, And what we've done is taken our spreadsheet and we've flattened it out like so. And then we've then merged in the test cases that we defined, and what you'll end up with is an explosion of the combination of the test data with the logic rules. So if you come in here, you'll actually see as the flags are set, the variables are set, they would then travel across like so, depending on the different types of data that you're running. Then it will run, so it resolves it first, more about that later. Then you get your results, and this is where it's gone off and run the actual transform, and you can see the result status here. And then finally we create an extra spreadsheet which has got some expected results calculation in it, which is actually result calculated status, and you can make this as sophisticated as you want, like so. And this is showing us the actual test cases that have failed. Now what's actually happened is that we've actually created the EDI file here, so just edit that, and you can see that this is actually it's a typical EDI file, very complicated. If you were trying to edit this by hand and manually edit it, it's very easy to make mistakes as to which ones are being added or missed or nulled, etc., etc. And then once it's run, then you would actually then open up the results file, and what we've done is we've written a small harness just to read that results file and actually pass that back then up into Modeler. And then if we refresh in here, you'll see we've actually got the combinations that have failed, and it's very easy to do this. You would also update Jira or HP ALM or whatever your ALM system is as well, so you can notify that this automation has failed and pass these results then back to the developers. So now we're going to have a little look at negative testing and subflows. So what I've done is created a subflow called invalid contracts, and what I'm going to do is put all of my negative or validation rules in a subflow, because it might be that we need to reuse this logic or this validation testing across other testing parts of the system. Again, in here what I've done is, if we go and look at our test data and the assignments, I'm setting various values. Now if you look in here, if you see agreement too long, what you can actually do is you can actually, previously we were putting our logic inside our spreadsheet, but what you can do is there is a full data editor in here, and you can see I've picked equals data gen, random string, fixed length, and all of our functions are available in here like so. And also you've got all of the normal Excel functions as well, so you can include those inside. So if you prefer, you can actually just do all of your test data definition inside here. So here we have our various different, let's look at the test generation. So in here, see if we've got any tests already. So we haven't created any tests yet, because this is going to, the tests are actually going to be created up in the master flow. So let's just close this. And let's go to our agreement and insurance. Now it's very easy to incorporate a subflow, so I'll just show you how you do that. You just literally drop it on here, go find it, expand it, and then you can just connect it any of the start or end nodes or waypoints like so in here like that. So just remove that, take it out. That. So that's how you do it. Now you can see I've already got one in here, and if I expand that, all you have to do is click on the plus and the minus and you get your little subflow like so. Now what I've done, if we go and look at our test generation, let's go and look at the different types of tests. Now I've done a full negative one. Now that's got full exhaustive tests. Now there's a lot of test cases because you've got n times n times n in here, and if we look at the tests, you'll see actually I think there's 100 odd of these different tests. 135 of them. But what I've actually chose is negative minimal, so I've gone for a basic set. What we could do is run this, and you can see I've run it before, and actually here you'll see that some of them have failed. And what you might want to consider then is to go to an exhaustive test, assuming you have time to look at it in more detail to try and track down what any problems are. So hopefully you'll see it's pretty straightforward. And all we're going to be doing, same concept, is we're going to be downloading. If we go and look at our tests and we do a download, now in this case you'll see for some of these you can see we're actually passing down the Excel function, so you don't need to go in and define it. So this will then be carried through into the automation logic when it's resolved and actually converted into specific values, which are then driven into the test cases and run via the automation harness. So hopefully you can see that's a kind of different approach. So in this case, we're doing all of the data definitions inside the model itself. In the positive one, we were actually just creating some sort of intermediary layer where we were defining the characteristics of the data that we care about. One key point is that the VIP TDM solution lets you look up and prepare data from multiple sources and targets. So this could look up back-end data. For example, the diary, which includes sale days, could be pulled from your live system, or you could invoke a Selenium script to look up valid shops and contract types, or indeed run an API to prepare some data that matches with your test cases. So all of your tear up and tear down logic can be performed using the one tool. So you have your TDM library. Now Excel has lots of plugins already, so you could actually just use your standard Excel, connect to an Olay data source, ODBC, etc., SharePoint, bring the data in using the VIP resolver functionality. You could also invoke a VIP flow directly from inside Excel, and that could make a call out to a web page. It could call an API. It can do all sorts of clever stuff, and it can bring that in then back into your resolved data set, which is then used by the system under test. You can also synthetically create data directly into databases as well. Then your system under test has a coherent set of data to read and a coherent set of matching data in the automation spreadsheets, which are driving the automation. So in summary, model the transform logic, design the type of coverage you care about, define your data rules and expected results, save time by communicating logic visually, updating tests quickly when a requirement changes, and in ETL that is massive. The amount of time you can waste going back through existing test cases is extraordinary. And of course you can increase quality by using mathematics to create your test. So that's it. These are the core takeaways, and of course feel free to get in touch if you want to trial or would like to discuss how we could help you build a more robust ETL and BI testing framework. Thank you.